Around the world, millions of people are infected with the AIDS virus, HIV. And although drug treatments can successfully suppress the virus to undetectable levels, rather like taking your foot off the brake in a car that's parked on a hill, if you stop taking the medication, the virus rapidly returns with a flourish and regains its momentum. And that's because of its ability to insert the genetic code of the virus into our own DNA and then hide in an inactive state in various cells around the body. So if we want to rid the body of HIV, we have to discover a way to flush out the virus from these hiding places. And just this last week, 2 papers have been published in the journal Nature proposing 2 new ways that we might be able to do that. My name is Chris Smith, and I spoke to Harvard researcher Matthias Lichterfeld, who wrote an article about the new research, and I asked him to take me through what's been discovered.
We have 2 studies here that are focusing on figuring out new interventions that could possibly lead to a cure of HIV. In a way, they really go to the central problem of HIV infection, which is that the currently available treatment is very good at suppressing HIV, but it is not getting rid of all HIV-infected cells. So there's a number of cells that can persist in the body, and they can actually persist lifelong, which means that treatment has to be given lifelong.
When the virus is hanging out in this way and persisting, where does it lurk?
That is a question that has been researched a lot over the last couple of years, and it really comes down to this ability of HIV to stay in what we call a sleeping position. So HIV is able to integrate its genetic material in the human DNA. Once it's there, it sort of stays silent and doesn't do anything. So it doesn't produce any active virus. And that is a very smart strategy because it allows HIV to escape from any type of immune activity that the human body could build against HIV. So it is one of the key strategies that HIV is using to persist lifelong.
So there's 2 pools of virus, as it were. The virus that's washing around in the bloodstream, infecting new cells, and this is in someone who's not having their disease treated. And then there's also a pool of virus which has gone into a bunch of cells around the body, hidden itself inside the genetic information of those cells, and essentially gone to sleep. So it's hiding, it's undetectable.
Exactly. It's sort of invisible to the immune system. Nobody knows where it is. And the immune system can't be doing anything against it.
So we can manage the circulating virus and suppress that very well, but the minute we stop taking drugs, then it would come back with a flourish from these sites in which it's hiding in this latent state.
That's exactly right. If you stop treatment, HIV would come back. Typically, it comes back within a couple of days or weeks.
What then is the strategy that's outlined in these papers for trying to get rid of this latent or hiding pool of virus?
Both of these papers are focusing on an approach that we call the shock and kill approach, to force HIV out of that sleeping condition. So to force it to identify itself and become visible to immune cells and make HIV-infected cells recognizable and targetable by immune interventions.
I suppose one way you could look upon it, it's a bit like going on a pheasant shoot, and you have beaters and dogs on the ground that scare the birds up, and then the guns can shoot them.
Yeah, exactly. That's what we call the shock component. So we try to flush out HIV out of the cells where it's hiding so that the cells can be identified by the immune system.
And in these 2 studies, what approaches do the 2 different groups take in order to make the virus show itself?
So the first paper is focusing on a host protein that has been identified as a very powerful stimulator of HIV production. So whenever that host protein is active, then HIV has to be expressed. And what's being used in that paper then is a drug that is sort of activating that host factor. And what these guys show then in the paper is that once they give that drug, HIV indeed comes out. Second strategy is using 2 different types of immune interventions. And one of them is a sort of a host signaling molecule that apparently has a very strong ability to bring HIV out of that sleeping condition. And it's used in combination with an additional intervention that eliminates a specific subset of immune cells that support HIV in its ability to stay in that sleeping condition.
Is this not risky, though? If you're directly manipulating the immune response of the individual, is there not a danger that it could trigger, say, autoimmune disease or some other kind of deregulation of the immune system?
Those are really good questions, and it's important to recognize that these two studies that we are looking at here were done in monkey models and in humanized mice, so clearly not in humans, and we are far away from translating any of these activities into humans at the current stage. These two studies were more designed to identify possible targets and possible interventions that could be used for disrupting that sleeping condition of the virus. They cannot be used in human studies at this point.